Over the span of a single lifetime, the world has changed in ways that would have been virtually unimaginable in the first half of the 20th century. Two major breakthroughs that occurred in physics, relativity and quantum physics, suddenly made a number of previously unthinkable endeavors possible. From modern electronics to computers, smartphones, the internet, brain imaging and more, everyday life in 2021 is vastly different from what it was back when many of us were first born. One of those technologies that's been revolutionary for our society is GPS, the Global Positioning System. From anywhere in the world, signals can be transmitted by a network of medium Earth orbit satellites to wherever your location is, pinpointing your position to an accuracy of better than 1 meter, 3 feet, more than 95% of the time. Devices with the latest, L5, receivers, released in 2018, are capable of reliably determining your location to within 30 centimeters, 12 inches. Unbeknownst to most people, however, the science underlying this technology was primarily developed by two people, Albert Einstein, whose theories of special and general relativity both play an important role, and Gladys West, a still living and largely unheralded black woman whose scientific contributions enabled us to understand geodesy and the shape of the Earth well enough to make GPS technology possible. Here's the science behind why this hidden figure of GPS is invaluable. Here on Earth, GPS is truly a technology that's only been possible since the dawn of the space age. At its core, GPS is enabled by a network of satellites that each carries an accurate record of its position in space and the passage of time on board, with the latter enabled by atomic clocks, one aboard each satellite. Those satellites continuously transmit their position and time data through a radio signal to receivers located anywhere on Earth. Since the speed of those radio waves, the speed of light, is a constant, anyone who receives a signal from any 4 GPS satellites at once, with known timestamps and position stamps, can determine their three-dimensional position in space and the position in time, i.e., your clock deviation, from the time on board the satellites. At an orbital height of 21,180 kilometers, 12,540 miles, a little more than 3 times the radius of the Earth, only 24 satellites are required to provide full coverage to the entire Earth at once. The United States GPS system, consisting of 31 operational satellites at present, serves the entire world. Physically, however, you have to know 3 very important things in order to translate those received signals, the radio waves arriving from the various GPS satellites, into both a precise and accurate position and time. Those things are: you have to remember why relativity, both the special and general versions, are so important. Up in space, these satellites orbit Earth at significant speeds, 13,900 km per hour, 8,600 miles per hour.